In this video, we are going to be looking at the addition and subtraction of vectors, and we'll do so using the triangle law and the parallelogram law. So first I have the vector A, which is 1, 4. So that means 1 unit to the right and 4 units upwards. So I'll let the tail of the vector A be here. So 1 unit to the right and now 4 units upwards. And then I have my vector B, which is 3 units to the right and 2 units upwards. So I'll let the tail of the vector B be at this point. So 3 units to the right, 1, 2, 3, and 2 units upwards, 1, 2. So now if I have the vector A plus the vector B, that'll be equal to 1, 4 plus 3, 2. So I'll add the x components together, so that'll be the 1 plus 3, and I'll add the y components together, which will be 4 plus 2. So I'll have the vector 1 plus 3 and 4 plus 2. So 1 plus 3 is 4 and 4 plus 2 is 6. So I'll have the vector 4, 6. And that will be A plus B. Now first, let's discuss how to add these two vectors using the triangle law. Now when using the triangle law to add two vectors, the head of one vector must connect to the tail of the other vector. So here we have vector A, where this will be the tail of vector A, and here will be the head of vector A. So the arrow always points to the head of the vector. So now we'll take vector B, and we put the tail of vector B to connect to the head of vector A. Now remember, vector B is 3, 2, so that's 3 units to the right and 2 units upwards. So from this point, we'll go 3 units to the right and 2 units upwards. So I'm counting 1, 2, 3, and then 2 units upwards, 1, 2. So now I have the vectors A and B, where the head of vector A is connected to the tail of vector B. And that's a requirement to add two vectors using the triangle law. So the resultant vector would be from the tail of A to the head of B. So the tail of the resultant vector would be at the tail of A, and the head of the resultant vector would be at the head of B. And this resultant vector would be the result of A plus B. So this is A plus B. Now if we were to count the horizontal distance and then the vertical distance, we'll see that we get 1, 2, 3, 4 units to the right. So that corresponds to this 4 here, 4 units to the right. And 1, 2, 3, 4, 5, 6 units upwards. And that corresponds to the 6 here for 6 units upwards. So we can clearly see on the diagram using the triangle law that A plus B will be the vector 4 units to the right, 6 units upwards, which would be 4, 6. Now let's discuss how to do the same addition using something called the parallelogram law. Now notice for the triangle law, we have the head of one vector, so that's the head of A here, is connected to the tail of B, which is at the same point. The tail of the resultant connects to the tail of A, and the head of the resultant connects to the head of B. Now for the parallelogram law, the tail of the two vectors must be at the same point. So I'll choose this point here where the tails of the vectors would be. So first let's draw A, which will be 1 unit to the right and 4 units upwards. So 1, 2, 3, 4. And now I'll use the same point for the tail of vector B. And vector B is 3 units to the right and 2 units upwards. So that's 1, 2, 3 units to the right and then 2 units upwards. 1, 2. So now what we'll do, we'll use these two vectors to form a parallelogram. So as you can see, I placed the vector B on top here because a parallelogram has parallel sides. So this side B here will be parallel to the side on top here. So from this point here, I just went 3 units to the right and 2 units upwards. And now when I connect these 2 points here, that will be the vector A. So again, I can see the vector A, 1 unit to the right, 4 units upwards. And this side is parallel to this side. So this is our parallelogram. Parallel sides here and parallel sides here. Now within this parallelogram, we have two diagonals. We have a diagonal here and we have a diagonal here. Now the vector that will represent A plus B will be along this diagonal. So notice that the tails of all three vectors are the same point, or you can say all three vectors leave the same point. And if we were to count, we have 1, 2, 3, 4 units to the right, and 1, 2, 3, 4, 5, 6 units upwards. So the vector A plus B would be 4, 6, which corresponds to the addition here and also what we did for a triangle law. So now let's discuss the vector A take away the vector B. So we'll have A take away B will be equal to 1, 4 take away 3, 2. So we'll be taking away the x components, so 1 take away 3, and we'll be taking away the y components, 4 take away 2. So we'll have the vector 1 take away 3 and 4 take away 2. So 1 take away 3 is negative 2 and 4 take away 2 is 2. So we'll have the vector negative 2 and 2. And that will be a vector A take away B. Now when looking at the triangle law and the parallelogram law for the subtraction of vectors, basically the triangle law and the parallelogram law deals with adding vectors. Now here we have A take away B, but we can write this as the sum of two vectors by saying A plus negative B is equal to A take away B. So now let's look at what is the vector negative B. So negative B will be equal to the vector negative 1 times 3, 2. So that'll equal to the vector negative 1 by 3 is negative 3 and negative 1 by 2 is negative 2. So we'll have the vector negative 3 and negative 2. And this will be the vector negative B. So if I were to say A plus negative B, that will be 1, 4 plus the vector negative 3, negative 2. So now we say 1 plus negative 3 and 4 plus negative 2. So we'll have the vector 1 plus negative 3 and 4 plus negative 2. So we multiply this positive and negative sign and we get a negative sign. So we'll have 1 take away 3. And we'll do the same thing here. We multiply plus and negative sign and we get a negative sign. So we'll have 4 take away 2. So we'll have 1 take away 3 and 4 take away 2. And as we know, 1 take away 3 is negative 2 and 4 take away 2 is 2. So we have negative 2 and 2. And this will be the vector A plus negative B. So you can see A plus negative B is the same as A take away B. So here I have my vectors A and B again. So now let's look at how to draw the vector negative B. So we have the x component as negative 3. So that's 3 units to the left. So I'll let the tail of the vector be here. So 3 units to the left would be 1, 2, 3. And then the y component being negative 2, that's 2 units downwards. So 1, 2. So we can clearly see the vector negative B is in the opposite direction as the vector B. Both of them have the same length, but they are in the opposite direction. So now using the triangle law to add vector A to vector negative B, we'll connect the tail of vector negative B to the head of vector A. So here I have my vector A, 1 unit to the right and 4 units upwards. And now at the head of vector A, I'll put the tail of the vector negative B. So from this point, I'm going 3 units to the left and 2 units downwards. So 1, 2, 3, and 2 units downwards, 1, 2. So now we have the head of vector A connected to the tail of the vector negative B. So for my resultant vector, I'll connect it to the tail of vector A and to the head of vector negative B. And as you can see, the tail of the resultant vector is on the tail of A, and the head of the resultant vector is on the head of negative B. So this would be my vector A plus negative B, which would be A take away B. And now if we were to count, we have 1, 2 units to the left, and then 1, 2 units upwards. So that corresponds with this negative 2, as we have 2 units to the left, and this positive 2 down here, where we have 2 units upwards. So negative 2 and 2 would be the vector A take away B. Now when using the parallelogram law for the subtraction of the two vectors, you'll draw the same parallelogram as if you were adding the vectors A and B. So I'm going to redraw the same parallelogram. So here I have my parallelogram with the vectors A and B leaving the same point. And remember, for the addition of A and B, we use this long diagonal here. As we can see here, this was A plus B. But remember, our parallelogram has two diagonals. So we have this long diagonal here, and we have this shorter diagonal here. So for the subtraction of two vectors, we are going to use the shorter diagonal. So now this would be the diagonal for the vector A take away B. Now notice I didn't put the arrow on it as yet. So we have to discuss which direction to put this arrow. Now obviously you're seeing from the triangle law, A take away B, the arrow is going in this direction. So it's going to be same here, the arrow is going to go in this direction. So now notice we have A take away B. So A is the initial vector and then B is the final vector. So the head of the vector will be at the initial vector and the tail of the vector will be at the final vector. So that's why the arrow is going in this direction. And as you can see, this vector is 1, 2 units to the left, so that's negative 2, and then 1, 2 units upwards. So that's in negative 2 and 2. Now using this theory that the head of the vector would be at the initial vector, which would be A, using the parallelogram law, we can quickly get what is the vector B take away A. So if you have the vector B take away A, then B would be the initial position and A would be the final position. So the head of the vector would have to be pointing towards B. And you can see that this vector is 1, 2 units to the right, and then 1, 2 units downwards. So the vector B take away A is 2 units to the right, so that's positive 2, and 2 units downwards, so that's negative 2. Now let's just work out what is B take away A and see if we get the same thing. So B take away A is equal to 3, 2 take away 1, 4. So we have 3 take away 1, which will be 2. And then we have 2 take away 4, which will be negative 2. So we can see we got the same answer as we got on the diagram, 2, negative 2.